Energy is the driving force that powers everything around us. It's everywhere. But what exactly is it, and where can we find it? In physics, energy is defined as the ability to do work, which essentially means it's the force that causes something to move or change position. It's what makes things happen. Though invisible to the human eye, energy is stored all around us in various forms, known as energy stores. One key principle to remember is that energy cannot be created or destroyed, only transferred from one form to another. So while energy is constantly changing, it's always present, powering the world in countless ways. Energy is stored in different forms, like gravitational potential energy, kinetic energy, thermal energy, chemical energy, elastic energy, nuclear energy, electrical energy, and electromagnetic energy. One of the most common types of energy store includes thermal energy, or heat energy, which is linked to an object's temperature. The higher the temperature, the more thermal energy it contains. This is because the particles inside the object move faster as they heat up, and their motion generates energy. For example, a hot cup of coffee holds more thermal energy than a cold one. Kinetic energy is the energy of motion. Anything that's moving, whether it's a car speeding down the highway or a soccer ball flying through the air, has kinetic energy. The faster an object moves, the more kinetic energy it possesses. Kinetic energy is also influenced by mass. As an object's mass increases, its kinetic energy increases as well, assuming the speed stays the same. This is because a heavier object requires much more energy, or work, to accelerate from rest to a certain speed, resulting in higher kinetic energy compared to a lighter object moving at the same velocity. Gravitational potential energy, or GPE, is the energy an object has because of its height above the ground. The higher an object is, the more potential energy it stores. When you lift an object, like a book, from the floor to a shelf, you're working against gravity and transferring energy to it. The higher you lift the object, the more energy it requires, and the more energy gets stored as a result. This energy doesn't disappear. It becomes gravitational potential energy, which can be released when the object falls. Now, if you lift a heavier book to the same height, it will have more gravitational potential energy than a lighter one. That's because more effort, or energy, is required to lift a heavier object, so it stores more energy. Chemical energy is a type of stored energy found in the bonds between atoms and molecules. It's the energy that holds these particles together, and it's released during chemical reactions. Think of it as energy waiting to be unlocked. Examples of chemical energy sources include batteries, food, petroleum, and coal. When a chemical reaction happens, like burning wood in a campfire, the bonds between the atoms in the wood's molecules are broken, releasing the stored chemical energy. One of the best examples of chemical energy in action is found in food. The food we eat contains chemical energy stored in its molecules. When we digest it, our bodies break down these molecules, releasing the stored energy that powers everything we do: walking, thinking, even breathing. This energy is vital for all living organisms. Electrical energy, the flow of charged particles. Electrical energy is associated with the flow of positively and negatively charged electrons. The movement of these charged electrons creates an electric current. In its most common everyday form, current is the flow of electrons in a wire, enabling the electric current to transfer from one device to another. We can harness the energy of these moving electrons to perform work for us, such as lighting a bulb, charging a device, or powering a motor. Elastic potential energy is energy stored as a result of applying a force to deform an elastic object. The energy is stored until the force is removed and the object springs back to its original shape, doing work in the process. The deformation could involve compressing, stretching, or twisting the object. When you compress or stretch a spring, it stores elastic energy, which is released to create a pushing or pulling force when the spring returns to its original shape. Everyday objects, like trampolines and bow and arrow sets, work similarly. They store energy when stretched or compressed and release it to generate movement or force. An object designed to store elastic potential energy will typically have a high elastic limit. However, all elastic objects have a limit to the load they can sustain. When deformed beyond the elastic limit, the object will no longer return to its original shape. Nuclear energy. Nuclear stored energy is the energy held within an atom's nucleus. It works through a process called nuclear fission, also known as splitting the atom, where atoms like uranium are literally split, releasing massive amounts of energy. This energy is harnessed in nuclear power plants to generate electricity. For example, in nuclear reactors, the heat produced from fission turns water into steam, driving turbines to produce power. Nuclear energy is also used in submarines and spacecraft, providing a reliable and long-lasting energy source. Electromagnetic energy. Electromagnetic energy is a form of energy that travels in waves, produced by the interaction between electric and magnetic fields. Unlike many other types of energy, it can move through empty space, which is why sunlight, one of the most powerful sources of electromagnetic energy, reaches Earth. We experience electromagnetic energy in different forms, like visible light, radio waves, and X-rays. A common example is using a microwave oven. Microwaves, a type of electromagnetic energy, are generated by a device called a magnetron inside the oven. These waves penetrate the food, causing the water molecules to vibrate and produce heat, cooking or warming the food from the inside out. So there you have it, 8 different energy stores that you interact with in your daily life. Keep in mind, energy itself doesn't change, it's simply stored in different ways. All these forms are just various examples of the same concept. Energy is what makes things happen. It's the driving force behind every action and process. Without it, nothing would move, function, or exist. Energy is essential to everything around us.